Thousands of years before satellites and space telescopes, ancient astronomers tracked planets with naked eye precision that would put modern star charts to shame. What they saw when they gazed upward wasn't just random dots of light. It was a celestial clockwork, a divine message board, and the very framework of their existence. From Babylonian priests predicting eclipses to Mayan astronomers calculating Venus cycles with jaw-dropping accuracy, these cultures built entire civilizations around the rhythm of the cosmos. Tonight, we're peeling back layers of time to reveal how humanity first decoded the universe using nothing but stone circles, hand-carved calendars, and minds brilliant enough to map the heavens without ever leaving the ground. Picture standing under a vast night sky with no city lights to dim its brilliance, just you, and an endless dome of stars stretching from horizon to horizon. To ancient civilizations, this wasn't merely a beautiful sight, it was architecture. They saw the heavens as a great, rotating sphere encasing the Earth, with every star and planet embedded in its surface like jewels in a colossal clock. This celestial sphere wasn't just a poetic idea, it was their ultimate tool for survival. Farmers used it to track seasons before seeds even touched soil. Sailors relied on it to cross trackless oceans, and priests interpreted its movements as messages from the gods. The Greeks may have given it a name, celestial sphere, but the concept was far older. Babylonian astronomers charted the stars on clay tablets as early as 1500 BC. While Egyptian priests aligned pyramids with the spheres turning, creating stone observatories that doubled as gateways to the afterlife. What's fascinating is how this model crossed cultures and continents almost unchanged. Whether in China, India, or Mesoamerica, people divided the heavens into the same constellations, mapped the same zodiac paths, and used the sky as both calendar and compass. Imagine the genius it took to predict eclipses or track Venus without telescopes, just careful observation, carved records, and celestial mechanics worked out over generations. Their sky wasn't random, it was a meticulously organized system, a blend of science and sacred geometry. Even today, remnants of this ancient wisdom linger in our star maps, a testament to humanity's first great attempt to tame the chaos of the cosmos. And yet, this was only the beginning. Among the sprawling cities of ancient Mesopotamia, where the Euphrates and Tigris rivers carved their paths through the land, a revolution was quietly unfolding, one that would change humanity's understanding of the cosmos forever. The Babylonians didn't just watch the stars, they studied them with meticulous precision, turning the night sky into a scientific textbook written in cuneiform. While other cultures saw omens in celestial events, the Babylonians saw patterns, and those patterns became the foundation of astronomy as we know it today. Their priests, often called Chaldeans, were more than just spiritual leaders. They were master astronomers, logging every shift in the heavens like cosmic accountants. They didn't yet know the Earth orbited the Sun, but they could predict eclipses centuries in advance using the Saros cycle, a repeating pattern of solar and lunar alignments they uncovered through relentless observation. Imagine the dedication it took to record celestial movements for generations, passing down knowledge on clay tablets that still survive today, bearing witness to their genius. What's even more astonishing is their mathematics. While we count in tens, they worked in base 60, a system so effective that we still use it every time we glance at a clock or measure an angle in degrees. 60 could be divided so cleanly into halves, thirds, quarters that it made their celestial calculations startlingly precise. They mapped the paths of planets, noted the changing brightness of stars, and even tracked the moon's wobbling orbit, all without telescopes. But this wasn't just about numbers, the stars were a language. To the Babylonians, a comet wasn't merely a celestial visitor. It could be a warning from the gods, a sign of war or famine. They believed the heavens held secrets meant to guide kings and nations. Yet beneath that belief lay something extraordinary, an unshakable faith in order, in rules governing the cosmos. That's what set them apart. While others saw divine whims, the Babylonians saw a system that could be decoded. Their legacy lingers in ways we rarely notice, from our 60-minute hours to the zodiac constellations we still reference today. They proved that science doesn't begin with high-tech tools. It begins with curiosity, patience, and the willingness to look up and ask, what if there's a pattern here? And in their case, there always was. While the Babylonians meticulously charted the heavens as a system of mathematical patterns, the Egyptians wove the stars into the very fabric of their mythology, turning the cosmos into a grand, living story. To them, the night sky wasn't just a map, it was the body of the goddess Nut, her star-studded form stretching over the earth like a protective canopy. Each evening, she swallowed the sun god Ra, carrying him through the hidden realms of the underworld before giving birth to him again at dawn. This wasn't mere poetry, it was their explanation for the cycle of day and night, a divine drama played out across the heavens. Their temples and pyramids weren't just monuments, they were celestial instruments. The Great Pyramid of Giza, for instance, was aligned with such precision that its corridors pointed directly to the pole star of its time, Thuban. And when Sirius, the brightest star in the sky, rose just before the sun, a moment known as its heliacal rising, it signaled the annual flooding of the Nile. This wasn't coincidence, it was a synchronized dance between earth and sky where the gods communicated through the stars. Timekeeping became an art form. The Egyptians divided the night into 36 decan star groups that rose in sequence, each marking roughly 40 minutes of darkness. This was one of humanity's earliest attempts to quantify time, a system so sophisticated that it influenced later Greek and Roman astronomy. But for the Egyptians, these weren't just practical markers. They were divine sentinels, each decan associated with its own god or protective spirit. What's striking is how seamlessly they blended science and spirituality. Astronomy wasn't a separate discipline, it was the language of the gods. Priests didn't just observe the stars, they interpreted them, reading celestial events as messages from the divine. A lunar eclipse might signal turmoil, while the steady rhythm of the decans reinforced the universe's order. This cosmic harmony mirrored their belief in Mat, the principle of balance and truth that governed both the heavens and human society. Even today, their legacy lingers. Our modern clocks still echo the Egyptian division of time, and their star lore survives in the constellations we recognize. But perhaps their greatest lesson was this: in a world where science and religion are often seen as opposites, the Egyptians found no contradiction. To them, the sky was alive, a sacred machine where gods and stars moved as one. And in that unity, they discovered both meaning and precision, proving that sometimes the deepest truths come not from separating the celestial from the divine, but from seeing them as inseparable. High above the olive groves and marble temples of ancient Greece, a revolution was unfolding, one that would change forever how humanity saw its place in the cosmos. Unlike earlier civilizations that blended astronomy with mythology, the Greeks dared to ask an audacious question: what if the universe operates by fixed rules rather than divine whims? This shift from storytelling to systematizing marks the birth of Western science itself. Pythagoras, known for his theorem about triangles, made another radical claim that the Earth itself was a sphere floating in space. While others imagined flat worlds carried on turtle shells or held up by giants, he noticed how ships disappeared hull first over the horizon, and how the moon's shadow during eclipses was always round. His insight wasn't just about shape, it suggested the universe might follow geometric perfection. Then came Aristotle, observing how different stars appeared when traveling north or south, and how eclipses cast Earth's round shadow on the moon. He envisioned a cosmos of nested crystal spheres, each carrying a planet or star in flawless circular motion, an idea so compelling it dominated Western thought for nearly 2,000 years. Though we now know these spheres were imaginary, their elegance revealed something profound. The Greeks believed the cosmos could be understood, not just worshipped. Eudoxus, a student of Plato, took this further by creating the first mathematical model of planetary motion. Faced with planets that sometimes slowed, stopped, or even backtracked in the sky, what we now call retrograde motion, he designed an ingenious system of interlocking spheres. Each planet moved on multiple rotating circles like cosmic gears, producing the observed loops and pauses. It was cumbersome, but it worked, proving mathematics could describe the heavens. Meanwhile, Hipparchus was compiling a star catalogue so precise it included not just positions but brightness levels. He even discovered the Earth's axis wobbles like a slowing top, a phenomenon called precession, by comparing his measurements to Babylonian records centuries older. Such meticulous record-keeping turned astronomy into a predictive science, not just an observation. What made the Greeks extraordinary wasn't just their ideas, many of which were later proven wrong. It was their insistence that the universe followed consistent laws waiting to be uncovered. This intellectual courage laid the groundwork for every astronomer who followed, from Copernicus overturning Earth's central place to Galileo proving the stars weren't perfect and unchanging. The Greeks taught us to see the cosmos not as a mystery, but as a grand puzzle one we're still piecing together today. While Greek philosophers sought universal laws through reason, halfway across the world in the dense jungles of Mesoamerica, the Maya were perfecting an entirely different, yet equally brilliant approach to understanding the cosmos. Their stone observatories weren't just buildings, they were precision instruments engineered to capture celestial events with breathtaking accuracy. At El Caracol, a spiral tower in Chichen Itza, narrow slit windows aligned perfectly with Venus at its most extreme points in the sky, a planet they worshipped as Kukulkan, the feathered serpent god linked to both creation and destruction. What's astonishing isn't just their observational skill, but how they wove astronomy into every aspect of life. Kings timed their coronations to Venus appearances, believing the planet's cycles infused them with divine power. Wars were planned around its movements as if the cosmos itself dictated human affairs. Their long count calendar didn't just track years, it spanned vast epochs of over 5,000 years, pinpointing eclipses and planetary alignments with a precision that still stuns modern scholars. This wasn't superstition, it was celestial engineering. The Maya saw the Milky Way as something far grander than a band of stars. To them, it was the Waka-chan, the world tree, with roots in the underworld, a trunk piercing the earthly realm and branches reaching into the heavens. This cosmic axis connected all layers of existence, a belief mirrored in their pyramid temples, which often served as physical manifestations of this celestial ladder. During certain times of year, the Milky Way's orientation even resembled a great serpent, another echo of their creator deity. Their mastery is etched into the Dresden Codex, one of the few surviving Maya books. Its pages contain astronomical tables so advanced they rival anything from medieval Europe, predicting lunar eclipses and Venus cycles centuries in advance. Unlike old-world astronomers who separated science from myth, the Maya blended them seamlessly. A solar eclipse wasn't merely an orbital event, it was a moment when the sun god battled underworld forces, a drama requiring rituals to restore cosmic balance. Perhaps what's most striking is how their understanding of time dwarfed even modern perspectives. While we measure in decades or centuries, the Maya calculated cycles spanning millions of years, seeing time as a series of repeating patterns rather than a straight line. This wasn't just math, it was philosophy, a world view where human history pulsed to the rhythm of the stars. Their legacy whispers a powerful truth. To truly grasp the universe, sometimes you need more than equations. You need to listen to the stories the sky tells. In the forbidden palaces of ancient China, where emperors ruled with the mandate of heaven, a single celestial event could shake an empire to its core. Unlike other cultures that saw the stars as gods or mathematical puzzles, China's imperial astronomers treated the sky as a bureaucratic ledger, every comet a memo, every eclipse a performance review from the cosmos itself. These weren't just stargazers, they were high-ranking officials whose observations could dictate wars, tax policies, even the emperor's very legitimacy. Records from the Han Dynasty reveal a system so rigorous it puts modern meteorology to shame. When a guest star, what we now know as the supernova creating the Crab Nebula, blazed into view in 1054, Chinese astronomers charted its position with such precision that modern scientists still use their data. They noted sunspots over 1600 years before Galileo, dismissing the idea of a perfect sun centuries before Europe even considered it. Their armillary spheres, bronze rings within rings, modeled the heavens with mechanical elegance, allowing predictions far beyond mere stargazing. The sky itself was organized like a celestial ministry. 28 lunar mansions divided the heavens, each corresponding to a season, a region of China, even specific government offices. A meteor streaking through one sector might warn of rebellion in a distant province, while Jupiter's steady path through another signaled imperial prosperity. This wasn't astrology, it was cosmic accounting where planets and stars balanced the books of state. Yet there was poetry in this precision. The Milky Way became the heavenly river, crossed once a year by star-crossed lovers in a festival still celebrated today. Eclipses required not just observation but action. Emperors would fast. Musicians would clash cymbals to save the sun from the mythical dragon swallowing it. Behind the ritual lay a profound idea that humanity wasn't separate from the cosmos but bound to it in an unbreakable contract. When the sky spoke, entire dynasties listened. What set China apart was how seamlessly they merged the practical and the profound. Their star maps, etched on silk or carved into stone, weren't just navigation tools, they were mirrors reflecting an ideal earthly order. A comet's tail might spell disaster, but it could also be a call to reform, a reminder that even emperors answered to something greater. In their hands, astronomy became more than science or superstition. It was the language of power, written across the night sky in strokes of fire and shadow. Beneath the vast, star-strewn skies of ancient India, scholars composed sacred texts that didn't just describe the universe, they encoded its rhythms into the very fabric of human existence. The Rig Veda, one of humanity's oldest surviving scriptures, speaks of a Hiranyagarbha, a golden womb from which all creation emerged. This wasn't mere metaphor. It was the cornerstone of a cosmic vision where time moved in immense, repeating cycles called yugas, each lasting hundreds of thousands of years. Imagine contemplating time not in decades but in epochs, where entire civilizations rise and fall like waves in an eternal ocean. The precision of India's celestial science still astonishes. The Surya Siddhanta, written over 1500 years ago, calculated the Earth's diameter and the Moon's orbit with errors of less than 1% long before telescopes existed. Temples like Konark's Sun Wheel weren't just places of worship, they were stone calendars, their corridors and carvings tracking solstices with razor-sharp accuracy. Even today, the first rays of the winter solstice slide perfectly down the axis of Tamil Nadu's Chidambaram temple, illuminating the deity's feet in a golden flare. But here's where Vedic thought diverged from the West. Instead of separating science and spirit, it fused them. The zodiac wasn't just constellations, it was a map of karma, with each planet's position at birth believed to shape one's destiny. Yet this wasn't fatalism, it was cosmic accountability. The nakshatras, or lunar mansions, linked specific stars to life's milestones, from marriage to harvests. When eclipses darkened the sky, rituals weren't just pleas to gods, they were acts of rebalancing, realigning human actions with universal order. What's remarkable is how alive this system remains. Modern Indian astronomers still reference the Surya Siddhanta for eclipse calculations, while millions consult Jyotish Vedic astrology for everything from business launches to medical treatments. The sky isn't just observed here, it's conversed with, a dynamic dialogue between human choice and celestial influence. In this worldview, the universe isn't a cold machine, nor a capricious deity, but a vast, breathing being, one that hums with mathematics, myth, and meaning in equal measure. Perhaps the deepest lesson lies in the yugas themselves. Unlike linear timelines where progress marches inexorably forward, Hindu cosmology teaches that creation spirals through golden ages, dark ages, and renewals. It's a reminder that even the stars have seasons and that every ending carries the seed of a new dawn. Now, let's set sail across the Pacific, where horizons stretched endlessly and the only roads were written in the stars. Picture this, a double-hulled canoe no bigger than a modern yacht, cutting through waves under a sky so vast it swallowed the sea. No compasses, no charts. Just the intimate knowledge of wind, waves, and the shimmering paths of constellations overhead. This was the world of Polynesian wayfinders, master navigators who crossed thousands of miles of open ocean with nothing but celestial intuition and generations of carefully guarded wisdom. At the heart of their craft was the Hawaiian star compass, not a physical tool, but a mental map dividing the horizon into 32 directional houses, each anchored by a guiding star or constellation. When the Pleiades rose just before dawn, it was time to launch. When Sirius stood directly overhead, they knew they'd reached the latitude of Tahiti. But stars alone weren't enough. These navigators read the ocean like a living text. The way swells bent around unseen islands, the flight patterns of birds returning to land at dusk, even the subtle shifts in watercolor that hinted at shallow reefs below. Every ripple and cloud formation told a story. What's staggering is the sheer scale of their achievements. Using only oral tradition, no written records, they settled islands from Hawaii to New Zealand to Rapa Nui, Easter Island, a maritime empire spanning 1/3 of the globe. Their voyages weren't accidental drifts, they were intentional round-trip expeditions, with navigators memorizing star sequences for journeys lasting weeks. Imagine the trust required, stepping onto a canoe knowing your survival hinged on someone's ability to recall the exact angle where Orion's belt touched the horizon at a specific time of year. This knowledge wasn't just practical, it was sacred. In Maori tradition, the Milky Way was Te Ikaroa, the celestial canoe carrying spirits to the afterlife. Hawaiian chants preserved star paths like genealogies, weaving navigation into cultural identity. When European explorers arrived with their sextants and chronometers, they assumed such feats were impossible without instruments until Polynesian navigators like Maupiailug stunned the world in the 1970s by sailing from Hawaii to Tahiti using only ancestral methods, reigniting a nearly lost art. Today, NASA studies Polynesian techniques to train astronauts in celestial navigation, proof that ancient eyes once saw farther than we ever imagined. Their legacy whispers a profound truth. Sometimes the most advanced technology isn't a gadget, but a mind trained to listen to the earth and sky in perfect harmony. And in an age of GPS, their star paths remind us that true direction comes not from satellites, but from remembering how to look up. As Europe entered its so-called Dark Ages, a brilliant light was shining in the Islamic world. one that would keep the torch of astronomy burning for centuries. While libraries crumbled in the West, Baghdad's House of Wisdom became a beacon of discovery, where scholars from across the Muslim empire gathered not just to preserve ancient knowledge, but to push it further than ever before. Here, Greek manuscripts by Ptolemy and Aristotle weren't merely copied, they were scrutinized, corrected, and reinvented. Take Al-Batani, a 9th century astronomer whose meticulous observations exposed flaws in Ptolemy's ancient models. Tracking the sun's path with unprecedented precision, he calculated the solar year's length with an error of just 2 minutes, a record that stood for centuries. His work didn't just refine Greek ideas, it shattered them, proving the Earth's orbit wasn't perfectly circular but slightly oval. This was more than accuracy, it was a quiet revolution, nudging astronomy toward truths that would later inspire Copernicus. Then there was Ulugh Beg, the royal astronomer king who turned Samarkand into a scientific powerhouse. His observatory, crowned by a gargantuan marble sextant, produced star maps so detailed they pinpointed star positions within minutes of arc, rivaling modern telescopic data. Imagine the ambition, a ruler who valued celestial measurements more than military conquests, believing the heavens held deeper glory than any earthly throne. But perhaps the most enduring legacy was their toolkit. The astrolabe, a handheld computer of brass and precision, could tell time, predict star positions, even calculate prayer times across latitudes. Muslim astronomers didn't just perfect this device, they transformed it into an artist's canvas, engraving them with ornate calligraphy and intricate star patterns. And when they gazed upward, they left their mark in the sky itself. Stars like Aldebaran and Altair still bear the Arabic names gifted to them over a millennium ago. What's often overlooked is how deliberately multicultural this golden age was. Persian, Indian, and Greek ideas fused in a collaborative spirit rarely seen in history. Caliphs sponsored translations of Sanskrit texts alongside Plato's dialogues, while Jewish and Christian scholars worked alongside Muslims in grand observatories. This wasn't just preservation, it was reinvention, proving that progress thrives where diverse minds meet. Islam's unique perspective fueled it all. The belief that studying the cosmos was an act of devotion, a way to glimpse the divine order. While Europe's monasteries debated theology, Muslim scientists were measuring the tilt of Earth's axis with tools they'd refined through prayerful precision. Their message echoes across time that curiosity and faith aren't opposites, but partners in the eternal human quest to understand the stars. And thanks to them, when the Renaissance finally dawned, the wisdom of antiquity hadn't been lost, it had been polished to a brilliant luster, ready to illuminate a new age. Beneath the sweeping skies of North America, where the horizon stretches uninterrupted for miles, indigenous peoples didn't just see constellations, they lived them. For the Lakota, the Big Dipper wasn't a random cluster of stars. It was Moto Tupila, the Bear's Lodge, a celestial guardian whose movements dictated seasonal hunts and sacred rites. To the Pawnee, the Milky Way mirrored the earthly Platte River, its starry currents guiding spirits to the afterlife. These weren't mere myths, they were maps, calendars, and moral codes etched in light. At Choco Canyon, where sandstone walls rise like ancient skyscrapers, spiral petroglyphs transform into solar daggers during solstices, a precise astronomical marker carved 1,000 years before modern telescopes. The Hopi, meanwhile, timed their snake dance to the rising of certain stars, believing the ceremony's rhythms harmonized with cosmic cycles to summon rain. Every ritual, every story tied human existence to the heavens in a way that blurred the line between science and spirituality. What's often missed is the sheer practicality of these traditions. The Skiddy Pawnee star charts, for instance, didn't just tell stories. They predicted the arrival of spring rains critical for planting maize. The Zuni called Orion twin war gods, using its position to signal the start of winter storytelling season. Even something as simple as the Pleiades rising could signal when to harvest or migrate, a fusion of astronomy and survival honed over generations. These narratives challenge the Western divide between science and legend. Where Greek astronomers sought geometric models, native cultures saw kinship, stars as ancestors, comets as messengers, eclipses as moments of communal realignment. The Navajo's black god, depicted with constellations on his body, didn't just rule the night, he was the night, embodying a universe where all things were interconnected. Today, as astronomers rediscover sites like Chimney Rock, a Puebloan observatory aligned to the lunar standstill, it's clear these traditions held sophisticated knowledge. Unlike the rigid celestial spheres of medieval Europe, indigenous sky lore remained fluid, adapting to each tribe's landscape and needs. Their legacy whispers a truth modern science is only now embracing, that understanding the cosmos isn't just about measuring distances, but about finding our place within a living, storied universe. Beneath the soaring vaults of medieval Europe's great cathedrals, where stained glass transformed sunlight into sacred storytelling, another kind of divine revelation was unfolding, written not in scripture but in stone and shadow. While modern narratives often paint this era as a dark age of scientific stagnation, the truth is far more fascinating. Monasteries became unexpected hubs of astronomical study, where monks like the Venerable Bede didn't just pray, they calculated. His On the Reckoning of Time wasn't merely a theological work, it was a groundbreaking fusion of faith and celestial mechanics, using the moon cycles to pin down Easter's shifting date with mathematical precision. Step into Chartres Cathedral at dawn on the summer solstice, and you'll witness a marvel of sacred geometry. A single beam of light pierces a tiny aperture, striking a worn brass marker inlaid in the floor, a solar alignment so exact it could set liturgical calendars. These weren't accidental features. Architects encoded the heavens into their blueprints, with pillars spaced to mirror celestial intervals and rose windows echoing the zodiac's symmetry. The church wasn't suppressing astronomy, it was literally building its foundations upon it. At the heart of medieval cosmology lay Ptolemy's ancient model, a complex clockwork of epicycles and deference that kept Earth firmly at the universe's center. Though we now know it was wrong, the system's elegance was undeniable. It predicted planetary motions well enough to guide navigators and farmers for centuries, proving even flawed frameworks can drive progress. Scholars like Johannes de Sacrobosco didn't blindly accept Greek wisdom. They refined it, compiling textbooks like the Sphere that became standard university fare from Oxford to Paris. Then there's Dante's Divine Comedy, where poetry and cosmology collide. His journey through hell, purgatory, and paradise wasn't just imaginative. It was meticulously mapped onto the Ptolemaic universe, with each sphere of heaven corresponding to a celestial body, from the moon's imperfect realm to the Empyrean's divine radiance. For medieval thinkers, this wasn't fiction. It was cosmic theology, a reminder that the physical and spiritual worlds mirrored one another. What emerges from this era isn't a clash between faith and science, but a collaboration. Monks tracked comets as divine portents while also noting their predictable orbits. Astrolabes adorned with crosses calculated prayer times alongside star positions. Even the Church's resistance to heliocentrism centuries later wasn't mere dogma. It reflected a universe where every element, from the humblest pebble to the highest angel, had its ordained place. In their quest to reconcile heaven and earth, medieval Europeans crafted a cosmos both ordered and enchanted, one where studying the stars wasn't just science but soul work. Imagine living in a world where every sunrise and planet's dance across the night sky seemed to revolve around you. That's exactly how Claudius Ptolemy saw the cosmos in the 2nd century, an intricate, Earth-centered clockwork that would define astronomy for over a millennium. His Almagest, a staggering 13-volume masterpiece, didn't just compile Greek knowledge. It built a celestial empire with Earth as its unchanging throne. At first glance, Ptolemy's model made perfect sense. The moon, sun, and planets moved along perfectly circular paths, or so it seemed, embedded in giant, transparent spheres that rotated around our stationary world. But there was a puzzle. Mars, Jupiter, and the others occasionally halted in the sky, backtracked, then resumed their journey. Instead of scrapping the Earth-centered idea, Ptolemy devised an ingenious fix: epicycles. Imagine a planet not just moving in a circle around Earth, but riding a smaller circle within that circle, like a cosmic carousel. This double motion created the illusion of planets looping backward, preserving the geocentric view while matching what observers actually saw. The brilliance and limitation of Ptolemy's system lay in its flexibility. By tweaking the size and speed of these epicycles, his math could predict planetary positions with surprising accuracy. Sailors relied on his tables to navigate, farmers used them to track seasons, and the church embraced them as proof of divine order. For 1400 years, his model wasn't just accepted, it was unquestioned. Yet beneath its elegance, cracks were forming. Over centuries, astronomers kept adding more epicycles to explain tiny discrepancies, layering complexity upon complexity, like a Rube Goldberg machine of the heavens. By the time Copernicus peered at the stars, the system had grown so tangled that he famously quipped it resembled a monster rather than a man. Ptolemy's enduring legacy isn't just a cautionary tale about human error. It's a testament to how even wrong ideas can spark progress when they sharpen our observations. His mathematics, however misplaced, honed the tools future astronomers would use to dismantle geocentrism. In a way, his epicycles were the scaffolding that held up the cosmos, until someone dared to ask, what if the scaffold itself was in the wrong place, the real lesson? Sometimes the most enduring theories aren't those that are right, but those that push us to look deeper. And in that regard, Ptolemy's mistake was one of history's greatest gifts to science. High in the Andes, where the air thins and the stars blaze with unparalleled clarity, the Inca engineered a celestial observatory unlike any other. Near their capital of Cusco, 12 stone pillars called sucancas stood sentinel along the horizon, their precise alignments marking the summer and winter solstices with uncanny accuracy. When the sun rose between specific pillars, it signaled not just a change of season but a sacred mandate: time to plant, to harvest, or to honor in Ty, the sun god who sustained their empire. This wasn't mere stargazing, it was statecraft written in sunlight and shadow. Far to the south, the Nazca Desert's enigmatic geoglyphs stretch across miles of arid plateau spirals, animals, and geometric shapes so vast they're only visible from the air. While theories abound, many scholars believe these lines weren't just art but a celestial map. Some align with the June solstice sunrise, others point to star clusters like the Pleiades, vital to agricultural cycles. Imagine etching a roadmap to the heavens so large it could only be decoded from the perspective of the gods themselves. Meanwhile, in the heart of Tenochtitlan, the Aztec sun stone, often mislabeled a calendar, reveals a cosmology where time and space collapse into a single sculpted narrative. At its center, the face of Tanatia, the sun god, demands sacrificial tribute to keep the cosmos in motion. Surrounding him, concentric rings trace the sacred Zu-Po-Hualli 365-day solar cycle and Tonal-Po-Hualli 260-day ritual cycle, whose interlocking rotations created a 52-year century when they realigned. More than a timekeeper, this monolithic disk was a covenant, humanity's duty to nourish the sun with blood, lest the universe grind to a halt. What unites these cultures is their audacity to build their cosmology into the land itself. Where Greeks theorized about celestial spheres and Babylonians charted clay tablets, The Inca sculpted mountains into observatories, the Nazca turned deserts into star charts, and the Aztec carved their cosmic contract into stone. Their astronomy wasn't separate from daily life. It dictated when to sow maize, where to place temples, even when rulers took power. Perhaps most revolutionary is how these systems defy old-world assumptions. Without telescopes or written records, indigenous Americans achieved precision rivaling anything in Europe or Asia. The Incas' sex system, a network of ritual pathways radiating from Cusco, doubled as an astronomical grid, synchronizing agriculture across an empire spanning rainforests and peaks. Their knowledge wasn't just academic, it was the glue holding civilizations together. These overlooked geniuses remind us that the quest to understand the heavens wasn't confined to one continent or culture. From solstice markers on Andean ridges to star-aligned glyphs in Peruvian sands, they proved that astronomy flourishes not through tools alone, but through the relentless human hunger to find order in the stars and meaning in their dance. In a quiet corner of 16th century Poland, a canon named Nicolaus Copernicus was quietly unraveling the universe, and he knew the world wasn't ready. While Renaissance artists rediscovered human form, Copernicus dared to redraw the cosmos itself, challenging a belief that had stood for 1500 years, that Earth sat motionless at creation's heart. His manuscript, De Revolutionibus Orbium Celestium, on the revolutions of the heavenly spheres, arrived on his deathbed in 1543 like a time-delayed bomb, its fuse lit by ancient Greek and Islamic astronomers, but its explosion destined to reshape everything. The brilliance of his model wasn't just in its conclusion, that planet circled the sun, but in its elegant simplicity. Where Ptolemy's geocentric system required dizzying epicycles to explain planetary loops, Copernicus' heliocentric arrangement made those loops vanish. Suddenly, Mercury's erratic dance and Mars' backward steps weren't celestial quirks. They were natural consequences of Earth also moving, like passengers on a carousel misjudging another rider's path. Yet for all its beauty, the idea was explosive. Demoting Earth from the universe's throne didn't just defy Aristotle, it upended theology, philosophy, and humanity's very sense of place. What's often overlooked is how deeply Copernicus stood on the shoulders of giants. His calculations leaned on Arabic star tables from Ulugh Beg's observatory, while his inspiration traced back to Aristarchus of Samos, a Greek who'd proposed a sun-centered system 2 millennia earlier but was dismissed as a heretic. Even Copernicus' famous diagram of concentric planetary orbits echoed the celestial spheres of medieval Europe. Only now the sun, not Earth, anchored them. This wasn't a lone genius striking lightning. It was a slow-burning torch passed across continents and centuries. The Church's resistance is legendary. Galileo's trial decades later would make that clear, but the initial reaction was more bemused than furious. Astronomers quietly adopted his math for its predictive power, even while publicly rejecting its cosmology. Protestant reformer Martin Luther scoffed that this fool wishes to reverse the entire science of astronomy. Yet within generations, Kepler would use Copernicus' framework to unveil the elliptical orbits of planets, and Newton would crown it with universal gravity. Copernicus' real revolution wasn't just about orbits. It was intellectual courage, the audacity to trust evidence over authority, even when it meant rewriting reality. HIS Chinese letter 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 DIDNT just moved the sun to the center. It placed curiosity there, proving that sometimes the most radical act isn't discovering something new, but daring to say aloud what the data has whispered all along. On an isolated island in the late 1500s, a nobleman with a golden nose and a pet moose was amassing the most precise celestial measurements the world had ever seen. Tycho Brahe wasn't just an eccentric Danish astronomer, he was a human observatory. with custom-built instruments the size of small buildings. He charted the positions of Mars and other planets to within 1/60th of a degree, all before the invention of the telescope. Every night, he logged data with obsessive detail, noting atmospheric conditions, instrument quirks, even his own potential errors. This wasn't just stargazing. It was a forensic investigation of the cosmos, and Brahe was determined to catch the heavens in the act of imperfection. Enter Johannes Kepler, a brilliant but struggling mathematician who saw in Brahe's numbers what no one else could: a hidden language. When Brahe mysteriously died in 1601, some say from a burst bladder after refusing to leave a royal banquet, Kepler inherited his life's work. Decades of Mars observations scribbled across thousands of pages. Where others saw random dots, Kepler glimpsed a puzzle. For years, he wrestled with the data, trying to force Mars' path into the perfect circles that Greek astronomy demanded. But the numbers refused to cooperate. Then, in a flash of insight, he tried something heretical. What if the orbit wasn't a circle at all? The breakthrough came not from philosophy or dogma, but from Brahe's raw measurements. Kepler realized Mars traced an ellipse around the Sun, a stretched circle with the Sun slightly off-center. This wasn't a minor tweak. It shattered 2,000 years of celestial perfection. By 1609, his first law of planetary motion declared, all planets move in ellipses with the Sun at one focus. His second law revealed planets speed up when closer to the Sun and slow down farther away, like a cosmic pendulum governed by invisible rules. A decade later, his third law mathematically linked a planet's orbital period to its distance from the Sun, proving the universe ran on a precise, predictable clockwork. What makes their partnership legendary isn't just the discoveries, but how they got there. Brahe, the meticulous observer, and Kepler, the visionary theorist, embodied science's greatest synergy, one man's eyes and another's mind transforming data into truth. Without Brahe's numbers, Kepler might have spent his life polishing outdated Greek models. Without Kepler's genius, Brahe's notebooks would have gathered dust as curiosities. Together, they didn't just correct astronomy, they redefined how we do science, showing that progress often lies at the intersection of patience and imagination. And their legacy, it rippled straight into the hands of a young Isaac Newton, who'd use Kepler's laws to unlock the force governing both falling apples and orbiting moons, gravity. The universe had always followed these rules, of course, but thanks to a moose-owning nobleman and a persistent mathematician, humanity finally learned to listen. In the autumn of 1609, a renegade professor in Padua did something revolutionary. He pointed a curious new Dutch invention toward the night sky. Unlike his contemporaries who used early telescopes to spy on distant ships, Galileo Galilei aimed his handmade 3-powered instrument at the heavens. And what he witnessed would ignite a firestorm. The moon, long believed to be a flawless celestial sphere, appeared pockmarked with jagged craters and shadowy valleys. Jupiter, instead of wandering alone, had 4 tiny stars trailing it in lockstep, moons orbiting another world, disproving the dogma that everything revolved around Earth. But the most damning evidence came from Venus. Its crescent phases mirrored the moon's, proving it circled the Sun, not our planet. Overnight, Aristotle's crystalline spheres and Ptolemy's Earth-centered universe crumbled under the weight of observable truth. Church authorities, wedded to literal biblical interpretations of an immovable Earth, retaliated fiercely. By 1633, the aging Galileo stood trial in Rome, forced to recount his findings under threat of torture. Yet, even under house arrest, he kept refining his work, smuggling out manuscripts that would inspire future generations. What made Galileo's telescope revolutionary wasn't just its optics, it was the audacity to trust what it revealed. Where others dismissed Jupiter's moons as optical illusions, he meticulously tracked their movements for weeks, compiling irrefutable evidence. His sketches of lunar terrain showed mountains casting shadows, challenging the idea that celestial bodies were ethereal orbs of divine perfection. For the first time, humanity had proof that the cosmos wasn't a static backdrop but a dynamic, imperfect, and knowable realm. The irony, his telescope, with its modest 20-power magnification, was weaker than modern binoculars. Yet it peeled back the curtain on a universe far stranger and grander than philosophers had dared to dream. Those humble lenses didn't just magnify distant objects, they widened the very horizons of human thought, proving that sometimes seeing more means first daring to question everything. The year was 1687, and a reclusive Cambridge professor was about to solve a mystery that had baffled humanity for millennia, with an apple's fall as his unlikely muse. When Isaac Newton published Philosophiae Naturalis Principia Mathematica, he didn't just describe gravity, he revealed the invisible hand that orchestrated everything from swaying tides to planetary orbits. For the first time, the same force that made apples drop also kept the moon tethered to Earth and planets circling the sun. The cosmos wasn't just orderly, it was mathematical, bound by laws as precise as clockwork. Newton's genius lay in synthesis, Kepler's ellipses, Galileo's falling bodies, even Hooke's theories on celestial attraction. He wove them into a single framework where every motion could be predicted using three deceptively simple laws. The first law shattered Aristotle's notion that objects naturally slowed down, proving that planets and cannonballs alike would move forever unless acted upon. The second law quantified how force shaped motion, while the third revealed an elegant symmetry. Every action had an equal, opposite reaction. But his masterstroke was universal gravitation, expressed not in vague philosophy, but in an equation so potent it could calculate the moon's tug on our oceans or the sun's grip on distant comets. Critics scoffed at the idea of action at a distance. How could gravity work across the void of space? Newton's famous reply, "I frame no hypotheses." He didn't pretend to know why gravity existed. He simply showed how it worked, letting the math speak for itself. This humility masked a revolution. By refusing to privilege celestial over earthly physics, he erased the ancient divide between the perfect heavens and the corrupt sublunar world. Halley's comet, once an omen of doom, became a predictable visitor. Tides, once the caprice of sea gods, now yielded to lunar trigonometry. Yet for all its power, Newton's universe had limits. His laws couldn't explain Mercury's wobbly orbit or the nature of light gaps that would later inspire Einstein. But in unifying the cosmos under a single set of rules, Newton achieved something profound. He gave humanity the tools to not just observe nature, but to decode it. The ancients imagined celestial spheres. Newton gave us a universe where the same force that guided stars also shaped the arc of a thrown stone, a cosmic democracy governed by equations instead of gods. And so, with a handful of symbols scrawled on parchment, the final pillar of the scientific revolution slotted into place, the heavens, once the realm of myth and mystery, had become a vast ticking mechanism, one whose gears we were now beginning to understand. By the flickering light of oil lamps in Babylonian scriptoria, scribes pressed styluses into clay tablets, recording celestial omens that would shape empires. If the moon is eclipsed when Jupiter is not present, the king will die, warns one cuneiform text, a chilling example of how ancient astronomers wove cosmic events into prophecy. Yet beneath the mysticism lay astonishing precision. The Babylonians had uncovered the Saros cycle, an 18-year rhythm where eclipses repeat, allowing them to forecast lunar and solar events centuries in advance. Their predictions weren't guesses, they were mathematical inevitabilities calculated using painstaking records stretching back generations. Half a world away, Maya scribes painted eclipse tables in bark paper codices, their long count calendar pinpointing celestial phenomena with surgical accuracy. At Chichen Itza, the serpent shadow slithering down El Castillo's steps during equinoxes wasn't just spectacle, it was proof of a civilization that could script the sky's drama. Unlike the Babylonians, the Maya didn't rely solely on cycles. They refined their math to account for lunar irregularities, achieving predictions accurate to within hours. To them, an eclipse wasn't merely an alignment, it was a cosmic battle between the sun and celestial monsters, demanding rituals to restore balance. Then there's the Antikythera Mechanism, salvaged from a shipwreck off Crete. This bronze marvel, dating to the 1st century BC, contained over 30 interlocking gears that modeled celestial motions like a mechanical universe in miniature. Turn its handle, and dials would display upcoming eclipses down to the hour alongside planetary positions and Olympic Games schedules. Scholars now call it the world's first analog computer, a testament to Greek engineering genius. What united these cultures wasn't just technical skill, but their dual vision of eclipses as both calculable events and sacred portents. The Babylonians saw them as divine verdicts on kings, the Maya as celestial warfare, the Greeks as planetary geometry. Their achievements remind us that science and wonder aren't opposites, they're partners. Before telescopes or calculus, these astronomers decoded the heavens by marrying observation to imagination, proving that sometimes the deepest truths emerge when we let the stars speak in both equations and epic poetry. And perhaps that's the greatest lesson. In an age where we've demystified so much, there's still magic in realizing how much the ancients knew, not despite their myths, but because of them. Picture this, it's 1800 BC in Babylon, and a farmer squints at the horizon where the sun rises near a particular cluster of stars. To him, this isn't just a pretty backdrop, it's a cosmic alarm clock. That's how the zodiac began, not as a personality quiz in modern magazines, but as a practical tool etched into clay tablets. The Babylonians divided the sky into 12 slices along the sun's annual path, each named after the constellation it contained. These weren't arbitrary, they marked planting seasons, flooding cycles, and royal omens. When the sun entered the field constellation, later Aries, it signaled barley harvest. In Scales Libra, the autumn equinox balanced day and night. This was astronomy as survival manual, written in starfire. Then came the Greeks, who took this celestial calendar and spun it into something deeply personal. By the 2nd century BC, Hellenistic astrologers had mapped the zodiac onto human lives, claiming the stars under which you were born shaped your temperament and fate. Aries became fiery ambition, Taurus stubborn strength, Gemini quick-witted duality, archetypes that still echo today. What began as agricultural waypoints morphed into a mirror held up to human nature, with planets like Mars and Venus cast as celestial actors in each person's drama. Fast forward to modern times, and the zodiac's resilience is staggering. Despite astronomy debunking astrology's mechanics, constellations have shifted due to Earth's wobble, so most horoscopes don't even match their original stars. The 12 signs thrive. They've leapt from cuneiform to Instagram, adorning coffee mugs and dating apps, repackaged as both pop psychology and artistic muse. Picasso painted zodiac motifs, Shakespeare peppered plays with astrological quips, and today's memes dissect Mercury retrograde like weather reports. This endurance reveals something profound. The zodiac's journey from Babylonian fields to birthday horoscopes isn't about accuracy. It's about our unshakable need to weave narratives in the stars. Whether ancient shepherds tracking seasons or millennials checking daily forecasts, we're still reaching for the same thing, a sense that the cosmos speaks our language. And in that way, the zodiac's real magic isn't in predicting futures, but in reminding us how deeply, stubbornly human it is to look up and wonder if the stars see us too. On the misty Salisbury Plain, where dawn light spills over ancient stones like liquid gold, a prehistoric masterpiece, stands Sentinel Stonehenge. This ring of towering megaliths isn't just a Neolithic mystery, it's a meticulously engineered celestial calendar. When the summer solstice sun rises, its rays slice perfectly between the heel stone and into the heart of the circle, flooding the altar with light. But here's what's astonishing: built around 3500 B. See, with nothing but antler picks and raw manpower, Stonehenge's alignments aren't approximate, they're precise. The monument doesn't merely mark the solstice, it celebrates it, framing the sun's farthest northward journey like a stone-crafted spotlight. Venture to Ireland's Boyne Valley and you'll find Newgrange, a passage tomb older than both Stonehenge and the Great Pyramid. At winter solstice dawn, something extraordinary happens. For precisely 17 minutes, sunlight pierces a narrow roof box, creeping down a 60-foot tunnel to illuminate the inner chamber's spiral carvings. This wasn't random chance. The tomb's builders calculated the angle of midwinter sunlight to the fraction of a degree. Imagine the intent behind this design: a society so attuned to the cosmos that they wove the rebirth of the sun into the very rituals of death. France's Carnac stones present another enigma. Over 3,000 megaliths stretch across the Breton landscape in eerie, parallel rows. Some scholars argue these aren't just burial markers but a colossal lunar observatory, with certain alignments matching the moon's extreme positions during its 18.6-year cycle. If true, it suggests Neolithic Europeans weren't just tracking seasons, they were mapping the slower, more mysterious rhythms of the night sky. What ties these sites together isn't just their age or their stones, but their shared language of celestial symbolism. From Scotland's Callanish stones to Portugal's Almendar's cromlech, these monuments reveal a pan-European fascination with cosmic cycles, a bridge between earth and sky. The builders may have left no written records, but their message is clear. They saw the heavens not as distant lights, but as a living, breathing force intertwined with agriculture, ancestry, and the eternal dance of life and death. Perhaps most striking is how these ancient observatories mirror sky-watching traditions across the globe, from the Inca's solar pillars to the Chacon's canyon alignments. It's as if Neolithic minds, separated by oceans and millennia, arrived at the same profound truth, that to understand the cosmos was to grasp the very pulse of existence itself. And in their silent stone circles, that wisdom still whispers. The flames that consumed the Library of Alexandria didn't just burn parchment and ink, they devoured entire constellations of human knowledge. Among the ashes lay star catalogues painstakingly compiled by generations of astronomers, their observations of celestial movements reduced to smoke. One survivor, albeit in fragments, was the work of Hipparchus, a Greek astronomer whose 2nd century BC star map was so precise it included coordinates for over 800 stars. What makes his catalogue extraordinary isn't just its accuracy, it's the fact we know of it only through the writings of later scholars like Ptolemy, who preserved fragments while other records vanished forever. Not all losses were accidental. When the conquistadors razed Mayan libraries during the Spanish conquest, they erased astronomical tables tracking Venus with near-modern precision tables that might have rewritten the history of science had they survived intact. Likewise, the Islamic world's Zij treatises detailed logs of planetary motions often exist today only as citations in later works, their original manuscripts long crumbled to dust. These weren't just lists of stars, they were the building blocks of celestial prediction, tools that let civilizations forecast eclipses, navigate oceans, and align sacred architecture with the heavens. Yet sometimes fate offers a second chance. In 2005, scholars analyzing a medieval parchment discovered something astonishing beneath its Latin text: erased Greek letters revealing fragments of Hipparchus's lost star catalogue hidden beneath layers of ink. Using multispectral imaging, they recovered coordinates for part of the northern sky, proof that his measurements were even more precise than previously believed. Similarly, Babylonian clay tablets, once dismissed as merchant inventories, turned out to contain meticulous records of Jupiter's movements, showing ancient astronomers could calculate planetary positions using geometric methods once thought beyond their reach. What's haunting is realizing how much we'll never recover. The Chinese astronomer Shi Shen's 4th century BC star charts, the complete works of Alexandria's female scholar Hypatia, the celestial maps of Polynesian navigators, all survive only as whispers in historical footnotes. Each gap in this cosmic archive reminds us that scientific progress isn't a straight line, but a flickering torch passed haltingly across millennia, sometimes dimming, sometimes flaring back to life. Perhaps the most poignant lesson lies not in what was lost, but in how fragments endure. Like starlight from long-dead suns, these scattered records still reach us, proof that even in ruin, humanity's oldest urge to map the heavens refuses to fade entirely. And in that resilience, there's hope. Every generation rediscovers echoes of forgotten skies, stitching together a tapestry of cosmic memory, one thread at a time. The irony, in our digital age where data seems immortal, we're repeating history's vulnerabilities. Hard drives degrade, formats become obsolete, servers crash. The past whispers a warning. Knowledge, no matter how brilliantly won, is only as permanent as our commitment to preserve it. And that might be the most timeless lesson the stars have left us. Beneath the dense jungles of Cambodia, laser beams pierce the canopy, revealing secrets hidden for centuries. LiDAR technology has uncovered something extraordinary at Angkor Wat. Its entire sprawling temple complex aligns not just with the cardinal directions, but with precise solar events. The central tower frames the equinox sunrise like a stone camera, while surrounding structures mirror the Draco constellation's pattern from 900 years ago. This isn't just archaeology, it's a dialogue across time where 21st century tools confirm what Khmer architects knew long before GPS, that the sacred and the celestial are inseparable. Half a world away in Mexico, Teotihuacan's Avenue of the Dead reveals another cosmic blueprint. Modern surveys show its alignment isn't due north, as once assumed, but precisely 15.5 degrees east, matching the Pleiades setting point around the time of its construction. The pyramids of the Sun and Moon frame celestial events with such precision that scholars now believe the city itself was designed as a mirror of heaven, its grid reflecting a forgotten star map. But ancient astronomy isn't just about rediscovering alignments, it's solving modern problems. In the Amazon, indigenous tribes use star lore to predict seasonal floods with uncanny accuracy, guiding conservation efforts in ways satellite data alone cannot. Meanwhile, computer scientists study the Mayan Long Count calendar for insights into cyclical coding patterns, adapting its elegant mathematics for modern encryption algorithms. The real revelation, these cultures didn't just observe the cosmos, they conversed with it, treating the sky as both clock and compass, teacher and collaborator. As we grapple with climate crises and interplanetary travel, their wisdom whispers a counterintuitive truth: progress isn't always about looking forward. Sometimes the most revolutionary ideas are written in starlight, waiting centuries for us to read them. As we stand under the same stars that guided Babylonian priests and Polynesian wayfinders, it's humbling to realize how far we've come and how much we owe to those first stargazers. Their universe wasn't cold or empty, it pulsed with meaning, a celestial tapestry woven with gods, omens, and the rhythms of daily life. Fast forward to today, where our telescopes reveal galaxies billions of light years away, yet that age-old sense of wonder remains unchanged. What's extraordinary isn't just the accuracy of their observations, like the Maya predicting Venus cycles or the Inca marking solstices with stone, but how they transformed the sky into stories. For them, a comet wasn't just icy debris, it was a message. The Milky Way wasn't mere stardust, it was a river, a serpent, a path for souls. This blend of poetry and precision is their true gift to us, a reminder that understanding the cosmos isn't just about data, but about connection. Modern science has unraveled many mysteries they could only imagine. We've split atoms, landed on the moon, and captured the birth of stars. Yet as the James Webb Telescope unveils newborn galaxies and rovers trace Martian dunes, we're still asking the same questions that haunted ancient astronomers. Where did it all begin? Are we alone? What's our place in the grand design? The tools have changed, but the curiosity, the sheer awe remains. So here's to the star priests, the temple builders, the navigators who trusted the heavens more than maps. Their legacy isn't confined to history books. It's written in our clocks, our compasses, even our childhood constellations. As you step outside tonight, take a moment to look up, not just with your eyes, but with their spirit of discovery. Whether you're an amateur astronomer or simply someone who loves a clear night sky, you're part of this unbroken chain of cosmic wanderers. The universe is vaster than ever, but the human urge to explore it hasn't dimmed. So what do you see when you gaze at the stars? Drop your thoughts below. After all, the conversation they started millennia ago is far from over, and who knows? The next great cosmic insight might begin with your own moment of looking up.